Okay, so like we had last year, all of the lectures will be recorded and posted to YouTube. And you know where to find all of that, including this introduction part. So if you miss anything, please go back and double check that. Okay, so Math 161. Well done on making it to Math 161. There's about 60 of you. So if you think about your class size from last year and then your class size from this year, it's gone down a bit. From now until the next year, there's 60 of you, maybe about 40 of you will then make it through. Okay, that's just from the statistics. So maybe it will be better this year, maybe it will be worse, but usually it's around 40. Okay, let's get through all of the boring admin stuff and then we can start with the fun U substitution. So you all know about the Learn pages. Please make sure you're using Learn 2026, right? Not the 2025, that's from last year. So I got the lecture details, you know all of that already. The class representatives, either we pick new ones or we keep the same ones from last year. Where's my class reps from last year? Oh, there's one there. The other guy, do you want to continue or should we pick new ones? You fine continuing? You also fine continuing? You're not fine. Okay, we need one lady. If you would like to be class rep, please put your hand up. Okay, I will pick one at random, except for the one from last year. So one of you will be picked. You will be the lady class rep. Okay, the year mark breakdown. Okay, everyone's eager to see this. So last year we didn't have any exams. It was just that, you know, the last class test and then the sub-test. This year we have exams, and every year from now on you will have exams. So the way it's going to work is there's going to be a class mark. This will be everything done throughout the year. And then a final mark, which will be 50% of the class mark. Again, everything done throughout the year, and 50% of the exam. Okay. So 1 3-hour exam at the end of the year, that will be 50% of your year mark. If you fail that, you know, there's issues there. Okay, so class mark, a little bit different to last year. So the total 100% for your class mark is split into 4. So the quizzes, that's the usual MCQ stuff from last year. You know, you pick your letters, match the columns and stuff. That will count 25% of your class mark. Okay, a little bit more than last year. The tutorial test, so that's the normal written questions, you know, after you do the tutorial, that will count another 25%. The class tests, there will be 4 of them, the same as last year. That will count 25%. And then the June test, that will count 25%. Okay, the June test will be similar to last year. It will cover everything from semester 1. Okay, so everything up to the last bit in semester 1, that will be the June test. And then your final exam has a different weighting to it. So 60% of that will be the semester 2 work, and 40% of that will be the semester 1 work. Okay, now the questions are all mixed up, right, for your final exam, but it's a rough weighting of 60% stuff we do in second semester, 40% stuff we do in first semester. Any questions on that? Okay, and then just a note with the class test for this semester and the June test for this semester. Okay, do not cheer until I've finished talking. They will be open book. Okay, good, no cheering. So there's pros and cons with that. The department wants it to be open book. The pros, obviously you have your books with you. You don't need to worry about memorizing all of the formulas and stuff. The cons, I can't give you stuff that you've already seen. Everything's unseen then. Okay, so you can use your book as reference, but remember last year we did like a rates of change problem and then I put that in the test, right? Not anymore, right? We can't do that. So, you know, pros and cons, that's how it is. We just have to deal with that. Okay, the test weighting will be around the same. So 75% calculation, 25% proof. The proofs may be done in the lectures, but it will be like the main thing and then like a little bit more, right? Just to make it a bit more different. But the calculations, that will be unseen. Okay. So June test as well, that will be open book. Second semester and the exam, that will be fully closed book. Okay. There's reasons for why they did that. They say you're very anxious. So they want to lower your anxiety by making semester 1 open book, semester 2 closed book. I just work here. I don't know. Okay. The timetable, please make sure you are following the green ones now for 161. And note here 161 TUT. So from next week, this Monday period now, that will be your tutorial. Okay. And then we have another lecture Wednesday, and then the lecture on Thursday. Okay, S3, you should know that. That was the same one that we had last year. Okay. Next, the syllabus. Okay. I'll show you the syllabus. Please don't start crying. Okay. That's the syllabus. Okay, it's a little bit more than last year. So last year, the syllabus was a little bit shorter. Okay, so that's all the stuff we did last year. Okay, and this is all the stuff we're doing this year. Okay, that's quite a lot more. Okay, just honestly, it's a lot. It's a lot to get through, but we'll manage. So this first bit here on U substitution, we started that end of last year. We're going to do a recap of that and then start some new stuff. This techniques of integration, this is the most important part. Okay, so please in your notebooks put a big star next to this when you start writing the notes. Okay, why? Well, because all of this is going to be used in this chapter here on calculating volumes and moments of inertia. If you don't know the integration techniques, you can't even start on these problems. Yeah. Then parametric curves. To find the length of a curve, we need to know all of the integration techniques. Differential equations, we need to know all of the integration techniques. Polar coordinates, that doesn't have anything there. Conic sections. Series convergence tests, you need to know all of the integration techniques. So you see it's repeated quite a lot throughout the year. Okay. So first semester will be these three. Okay, so from chapter 1 to chapter 3, that will cover first semester. And then second semester will be chapters 4 to 8. Okay, that will give you the rough splitting of the work. Okay, next, absentee online form. Okay, so if you're absent for any lectures, tutorials, or tests, please make sure you follow the link here. Okay, and then you can put your details, right, name, surname, student number, what you missed, and so on. That will then be used for the catch-up. Right, if you don't fill this in, I don't know you missed the test, it's just going to be a 0. Okay, so fill this in, and then you'll be on the list for the catch-up. Okay, that was the absentee, modules, rules, and procedures. Same as last year, please just follow the link, read everything, fill that in. Textbooks, already problems. Okay, textbooks and notes, same as last year. So the textbook is the same, the Stewart textbook. If you have not bought the Stewart textbook yet, go to Shepston building. You all know where that is. Okay, there's usually guys there selling old textbooks. See if you can find it. It'll be very helpful for this year and especially next year. So next year when you do the MATH161, the lecturer doesn't provide like notes like this or the textbook. But if you have a physical one, it will help a lot out with that. Okay, so this will help you a lot for the 238 next year. Okay, then there's the other notes here. You've got this from last year. Extra integration. This is on the integration techniques. You see I wrote here, do these very important. I didn't write that for nothing, so please make sure that you go through that. All right, you're all big now, so no one's going to be checking your work to see if you've been doing these. But if you don't do these, please don't come crying at the end of the year saying, "Sir, I failed. Please help me." Okay, I can't help you at that point. Please do these. So there's part 1, part 2, and there's some extra problems on U substitution. So by the end of the semester, you should be done with these part 1s and part 2s. if we have a quick look at these, here's part 1. There's 69 of them. Okay, please make sure you start looking through these. So some of these we've already done, like these first 2 here. All right, just normal U substitution. Other ones, a little bit more difficult. Okay, but please make sure you do all of these. So that's part 1, and then part 2. Okay, there's another 48 of them, all different. So 69 from the first one, another 48 to try here, and then there's some more problems here to try as well. Okay, again, that's up to you to do. If you don't do them, that's up to you. But if you fail, again, that's on you. YouTube channels, that's the same as last year. I added this last one here. It's quite helpful for the work we're going to be doing. Okay, lecture notes, this is where I put the PDFs of all the stuff that I write during the lessons. You know that from last year. Weekly tutorial work. So here, it's a little bit different from last year. Okay, so here you have all of the tutorials. So just open here, it will give you everything you need to do. That will be up to you to do. Okay, the solutions are already available, so you can work ahead if you want. During the tutorial time, there will be a tutorial assignment that you'll need to do, okay, during that first hour. Okay, so the way that's going to work is you're going to be in groups. Okay, you're going to choose the groups yourself. If you don't have a group, I will put you in a group. You will do the assignments in a group, and the group tutor will then check your work. The reason for this is the university wants you to work in groups more, because the pass rate for next year was absolutely terrible. And the reason was, as the students say, the students work alone. Then when they get to the tests, they don't know what to do. So they want to try work together. So now that's on us to then put you in groups and start your study groups and tutorial groups now, so that when you get to Math 238 next year, you already have a study group to work with. Okay, I think it's an all right idea. We'll see how it goes. Now, you've been with each other for a year now, so I'm sure you've all made some friends. So please, can you get into groups of minimum 3, maximum 5? Okay, we don't want too big of a group. Okay, so whatever friends you got, just get together. And please email me with your group members. So elect a group leader. They will then send me a list of the 3 to 5 members in your group. That will be your tutorial group for the whole year. Okay. Has everyone got friends for a group? Everyone's got friends. Okay, that's great. Okay, so please do that by the end of today. Get your groups together, get your group leader, and please send me that email. Okay. If I don't have your name, then I'm putting you in some group. Okay. Maybe you don't like them. Tough luck. Okay, so then that will be the tutorial. You'll have the tutorial assignment. Then after that, we will have the usual quiz and tutorial test. Any questions on that? All good. Okay, class test, catch-up test, you know that from last year. Exam information and scope. So over here, I will put the scope for the final exam. It should be set by the end of this semester, so you can see what you need to be focusing on. Okay. Then lastly, past assessments. There are the past exams for 161. Please download this, have a look through that, see what the difficulty is like. And then some past class tests as well. Okay. Also, I have some hard copies of the exams over here. There's not enough for everyone, so you can fight for it over here afterwards. Okay, so I'll leave them over here. End of the lecture, you figure out who gets those or not. Okay, no fighting in the lecture venue. You can fight outside there. All right. Any questions about all this admin stuff? Everyone good. Okay. So end of today, I will post the 2 class reps. And please make sure you send me that email with your tutorial groups. Okay. Let's start with the lecture. Okay, so everyone's kept their notebooks from last year, right? So I gave you a very nice warning of don't burn your notebooks. We're going to carry on this year. Everyone's kept that. Okay. I suggest you buy another notebook for the tutorial work so that you can have your notes in one book and all of the calculations in another book. Okay. So why? Well, for one, the semester's open book. So you want to go through your notes quickly. You don't want to have like 20 pages of calculations if you just want to find a definition. Okay. Or if you get to your test and there's a calculation, you've seen something like that before, you go through your calculation book and you can see all of them quite easily. Okay. So it's just a nice way of splitting up the notes versus just the pages of calculations. Okay. Any questions before we start? You're all good. Okay. Just with the aircon, doesn't seem to be working all that well. So class reps, please can you send an email to Mr. Evans complaining about the aircon, and then hopefully it gets fixed soon. Okay. So first job is class reps, please complain about the email. Okay, so we're going to continue with U substitution. Or U sub for short. So we'll do a quick review from what we did last year, and then we'll start with the new stuff. Okay, so the idea for U substitution for indefinite integrals is if we have the following function, f of g of x multiplied by g prime of x, okay, we have something like that, then we can simplify this with a U substitution by letting U be equal to the inside function. Remember, outside function, inside function, we let U be the inside function. Then we calculate du. So du, that's du by dx dx. In this case, that's just going to be g prime. Okay, which is great because g prime of x dx, that takes care of everything there on that right side. So this becomes the integral of f of u. The inside part becomes u, and everything else on the side there, that becomes du. And the hope for U substitution is that this integral here is simpler than what we started with. Okay. Sometimes it's not simpler, then U substitution doesn't work. We have to try something else. That will be what we're going to look at for the remainder of the semester. Okay, the other methods that you can use. However, all of the examples now, we can use U substitution. Sometimes it's a little bit difficult getting started, but it is possible. Okay. Later on, when we do the other methods, I won't tell you which to use. That will be up to you. Okay. But always look for U substitution first. Okay. So that is for an indefinite integral. Next, if we have a definite integral, that means we have some bounds like going from a to b. We need to change the bounds. So if we have the integral from a to b, f of g of x g prime of x dx. We do exactly the same thing. U equals the inside part. So du, that will be g prime of x dx. So that's all the same. And now one important thing that my class from last year kept leaving out, change the bounds. Okay, please remember to change the bounds. So at the bottom, that is x equals a. So if x equals a, u will be equal to g of a. Yeah. And at the top, that's x equals b. If x equals b, u equals g of b. Okay, so please put a box around this. This is the extra step that you need to do if you have a definite integral instead of an indefinite integral. Okay, so now our new integral becomes the integral with the new lower bound. Instead of a, it's now g of a. And instead of b, it's now g of b. And instead of f of g, it's now f of u. And the g prime dx, that just becomes du. And again, the hope is that this new integral is easier than the previous one. Again, not always. Sometimes you need a different integration technique, but this should always be your starting point. Yeah. Any questions on this u substitution? You're all good. Okay. Let's have a look at some examples. Now, these examples won't be at the standard of last year. These examples are the standard for this year. Okay, so please don't get confused between these examples now and the easy ones we covered last year. Okay, so all the stuff we covered last year, please consider that the easy problems. These will now be the more medium type problems. Okay, so number one, we have the integral e to the x over 1 plus e to the 2x dx. Okay. What can we do? So let's say you get this for class test 1. We need some u that should help simplify this. What can we pick? Okay. So maybe you don't see it right away, but if you don't, we can always rewrite this. Okay, remember your algebra stuff. Let's write this not e to the 2x. We're going to write it a little bit differently. Maybe we can write it like that. Remember, e to the 2x is the same as e to the x squared. Please remember your algebra from last year. Now, in this form, we can clearly see some inside function, outside function, right? We have the brackets there. We have something squared. And there's something inside there is e to the x. So let's let that be u. Right? It might not be obvious, but it's something we can see. Outside function, inside function. Let's just try. Okay. Now, I know this is the right choice, but for you, it's just something to try. If it works, it works. If it doesn't, you just try something else. Okay, so if u equals e to the x, what's du? E to the x, yeah. Okay. Now that e to the x dx, that takes care of everything at the top there, right? E to the x dx. So that whole top bit, e to the x dx, we can replace with du, and the whole bottom part can be replaced with 1 plus u squared. Now this we've seen before. What's this integral? Tan inverse, yep. Always remember your plus c. Now this is in terms of u, right? We don't want that. We want this in terms of x. So the u equals e to the x. We substitute inside and we get our final answer. Okay. So you see it's a little bit more difficult than what we looked at last year. So last year it was straight. We could see outside function, inside function, and we did the substitution, right? It was like root 2x plus 1. You know exactly what's the outside, what's the inside. In this case, we had to do a little bit more work before we could see what is the outside, what is the inside, right? Yeah, that little bit extra there, that obviously counts for more marks. But also, if you don't see that, then you don't even know where to start. Okay, so please keep that in mind. You might need to do some work first before it looks like something you can do with a u substitution. Like the e to the 2x to e to the x squared. Any questions on this one? Oh, good. Okay. Number 2. we have 1 over x log x dx. Okay. Now here, there's no inside function, outside function, so we're a little bit stuck. Now, for the choice of u, we only have a few options, right? We've got the x there, we've got the natural log of x there. So we need to pick, right? There's no strict, this is inside, this is outside, so we can't do that anymore. So which one should we pick? The x or the natural log? The natural log. Yeah, that's a good guess. Why? What's the derivative of the natural log? 1 over x. We've got 1 over x there. So that's the choice that we make. Right. Again, with this u substitution, it's not a fixed rule. You see it, you figure out what to do. Okay, last year it was a fixed rule. You had inside, you had outside, you choose u to be the inside. Now that's not the case anymore. Okay, so we say u equals the natural log of x. Du is 1 over x dx. And that takes care of the 1 over x that we've got there. So this becomes the integral 1 over u du. What's that integral? Yep, natural log. Good. Please remember your absolute values there. Now, this is in terms of u. We don't want that. We want this in terms of x. So we take our u from above here, we substitute it in, and we get the natural log of the natural log of x. Okay. Any questions for this one? Okay, cool. Next one, number 3. Here we have the integral of sine cubed x over root cos x dx. Yeah. So we've got something like this. Now, at the bottom, we do have a composition. We've got square root of cos x. So we've got the outside function, inside function. Okay, so that helps a little bit. But the top there, that is sine cubed. Let's just rewrite that a bit. Okay, we got sine cubed at the top. So we have an idea for u, right? It can be cos, that's fine. Okay, so u equals cos. But what happens to the top? It's going to be an issue, right? Because we have u is cos. The top isn't written in terms of cosines. It's written in terms of sine. So again, there's a little bit that we have to do with that. But we got the hint from the bottom, let u be cos, and we'll see what we get. So what's du going to be? Not sine? Minus sine. Okay, please do not mix up your derivatives and your antiderivatives. Remember, you got those two tables, the one with the derivatives, one with the antiderivatives. This always has that minus sign difference, okay, between the two. Now, in our original integral there, we have sine cubed, so that's a pretty good start. We've got the sign there, but we don't have the minus sign. That doesn't appear. So let's take it over to the other side. Okay, so that helps a little bit. We've got sine x, but the top is still sine cubed. Okay, not sine. So we need to try something else. Let's factor out one of the signs. So we're left with sine squared and sine. Okay, seems a bit odd. Why are we factoring it like that? But you'll see in a bit. So integral sine squared and then the sine. Okay, so why am I doing that? Well, for the du, we need a single sine term. In the top there, we have sine cubed. We only want one of them, so let's factor it out. So sine x dx, that becomes minus du. So let's put a little bubble around that. That becomes minus du there. Now let's look at the bottom part. We have roots of cos x. That was our u. U was cos. So this bottom part, we can just substitute u equals cos. What about sine squared? What can we do with that to make it in terms of u? We have sine squared. We want to write it in terms of u, and u is cos. How do we get from sine squared to something with cos? Yep. Not derivatives. It's just an identity. No, not the half. 1 minus cos squared, yeah. So just on the side here, we can write. Oops. This pen. Okay, so the idea is to use a trig identity. So we've got sine squared. We know sine squared plus cos squared is 1. So sine squared is 1 minus cos squared. And we know cos is u. So we can replace all of that there with 1 minus u squared. Now everything is in terms of u. So let's write that on the side here. The stamp pen. Maybe it's the battery. The heat is killing me. Ugh. Okay, there we go. Okay, so we have sine squared plus cos squared is 1. I think we're going to do one more problem and then we'll leave it at that. Okay, so I've got 5 here. So we'll finish this one. The other 2 we'll leave for homework for you to try. And then the rest we'll carry on next time. So let's just finish this one. And then we can go. So we've got sine squared plus cos squared is 1. We want sine squared. So let's take the cos squared over. Okay. And we know cos is u, so we can substitute that. Okay. So let's put everything together. So sine squared, that's going to be 1 minus u squared. Okay, then the sine x dx, that's going to be minus du. And the bottom, that was root cos x, that just becomes root u. Okay, the minus sign we can just take out to the front. Okay, 1 over root u. Remember, root u is u to the half. So 1 over that will just be u to the minus a half. Okay, u squared over root u. What does that simplify to? So it will be u to the something. Or what will it be? 3 over 2. Who said 3 over 2? Okay, what's it going to be? U squared over root u. Three over 2. Everyone agree? Okay. Okay, and now at this point, it's just normal power rule, right? Add 1 to the exponent, divide. So the first one over there, minus a half, add 1, that makes it a half, divide by half, that's timesing by 2. Okay, then we have a plus from the minus there. Minus minus gives us a plus. Add 1 to the exponent, that makes it 5 over 2. Divide by that will be 2 over 5. Plus c. Okay, now we can't leave it like this. We have to put x back. So u is cos x, so we can substitute that back. Okay. Any questions for this one? They're all good. And again, please note all this extra work we need to do. So it's not just pick u, substitute, right? There's more work that we need to do for these problems. Okay, so the other two I'll leave for homework. So number 4, we have the integral 1 over root x plus root x plus 1. Okay, I'll give you a hint for this. We don't want to work with the roots, so you should rationalize the denominator. Right? So think back to your matric work, with the surds and all of that. So rationalize the denominator, then it should be much easier to do. And number 5, we have the integral x over root x minus 1. This one's pretty straightforward. You don't need any hints for that. Okay. Any questions for the homework? You're good. Okay, so please take that down. We'll go through that in the next lecture, and then we're going to be looking at integral functions. Okay, so please remember, end of today, please send me your tutor groups. Okay, so pick one member from your group to send me an email, and then just give me a list of who's in your group. By the end of today, if I do not have your name in a group, you will be assigned to a group randomly. Okay, everyone understood? Okay.